Welcome back. And in this lecture, you will learn about core machine learning models, or core ML for short. Core ML is a trained model that applies a machine learning algorithm to a set of training data. The model makes predictions based on that new input data. Core ML is the foundation for domain specific frameworks and functionality. CoreML supports the vision framework, which applies high performance image analysis and computer vision techniques to identify faces, detect features, and classify scenes in images and video. Then there is the foundation framework, which accesses essential data types, collections, and operating system services to define the base layer of functionality for your app. There's also Gameplay Kit for evaluating learned decision trees. And CoreML itself builds on top of other Apple deep learning frameworks like Accelerate and BNNS, as well as metal performance shaders. So with CoreML, a model is just a function learned from data. The logic from this function is learned from data. It then takes the inputs and gives us an output. CoreML supports multiple neural network implementations, from encoding a sentiment analysis function in a feed-forward neural network to predicting text in a generalized linear model. So where do we get these models? Well, we go to developer.apple.com/machine learning. Here you'll see two of the models. One, which detects the scenes of an image from 205 categories. The other, which detects the dominant objects present in an image from a set of 1,000 categories, such as trees, animals, food, vehicles, people, etc. Both of these models we will be implementing in our final two projects. CoreML is compatible with Mac OS, iOS, Watch OS, and TV OS. So with that, let's build a neural network with CoreML. So go ahead and open up your Project 3 starter project if you have not done so already. And as you can see here, I've already dragged in the model for this CoreML project. And you'll see that the evaluation parameters has the inputs as a scene image sized at 224 by 224 pixels. And the description is an input of an image of a scene to be classified. And it outputs a dictionary that is a string and or a double, along with the probability of each scene. Once you drag in a model, a class is automatically generated for you. If this is not highlighted, if it's all grayed out, then make sure with this highlighted over here that you go over here in your utilities pane and go down to where it says target membership and make sure that there is a check mark there where it says the name of your project. This was going to be the second project, but I made it the third one because I wanted to do the BNNS versus metal. So that's why that says that. Nonetheless, make sure it's checked and this will be highlighted. And if you click on this, you'll see where it tells us that the file was automatically generated and it should not be edited. And it looks something like this. So that file was automatically generated once the model was dragged into the project. So we want to call this model into our project. So the first thing that we will do is assign the model to a constant in our project view controller. So let's do that now. So now we need to get the scene for a specific image. Now we need to interact with our model. So now it is asking us for a CV pixel buffer, in which I've already done here. So we won't have to go through all of that code in our view controller. So instead, we'll create a constant that we can attach our image processor to and add a guard statement with a return scene. So let's do that now. So now we can use the scene label function to call it to analyze the image. And so with that, let's run our app. And as you can see, if I tap the picture, it's a construction site, a bamboo forest, and a sea cliff. So you could add your own pictures if you like. Just make sure that they are 224 by 224, and you would put them in the assets folder and then select them from the utility window. If you have any questions, send me an email or put it up for discussion, and I will respond expeditiously. That concludes our CoreML model first project. We will be implementing another CoreML application in our next project. See you there.